80% of the Postgres table.
Those cannot be slow. Those need to be very, very fast.
It's not easy.
It's not going to happen like super quickly.
Hey guys, today we have the pleasure to host Patrick Wendell. Is a co-founder and vice president of engineering at Databricks. He also helped launch Databricks in 2013, and he was also one of the founding committers of Apache Spark. Hi, Patrick. Hi, Quentin.
Hey, thanks for having me, guys. I'm happy to be here.
Yeah, thanks, Patrick. So maybe let's start with the basic. Can you tell us a bit more? Well, let's say, what did you work on when you start working on Databricks? I saw you worked a bit on Spark, and then what are you doing now, and what was kind of the journey to get there?
Yeah, good question. So let's see. So my career history is pretty simple because I did my undergraduate at Princeton, and then I went to Berkeley and the reason why I went to Berkeley was to work with the team that became the founding team of Databricks. So I was familiar with their work, and they were doing very interesting work in the space of kind of distributed computation. At the time, the work was more about scheduling and resource management. It was this project called Mesos. That was a really long time ago, so people probably don't know that largely, but that was interesting work. And then they were just starting to get more into the data analytics space. The general problem they were looking at was dealing with very large scale computation, and that had recently become much more commoditized, more available because of some hardware and software innovations that had happened. So I thought it was a cool team, and they were doing interesting work. And then I joined that team, and then I only stayed 2 years at Berkeley before I was doing a PhD, but then we left to start Databricks in 2013. So I didn't get very far into my PhD. We became more interested in the commercial aspects of the software. We actually tried to give away the software and get the existing companies to use it. So Spark was just starting when I went there, and I helped build the initial versions of Spark. And funny enough, we tried to give it away to people. We went to all the companies because we were just doing research. We thought, hey, let's get people to use this stuff so we can write some papers. So we made everything free. It was open source, and then a few companies would use it. A lot of the end users would use it, but then the vendors that are the ones that control the distribution of the data analytics software didn't want it. They said, "Oh no, we have better stuff. Our products are better." And we said, "Are you sure it's free? You really don't want this?" And then it was actually for that reason that we went and started the company, because we felt, okay, well, if no one else is gonna, commercialize this stuff, then I guess we're the only ones left to do it. So I left to start Databricks with that team in 2013, and since then, in the early days, we were all just engineers. There was nothing else to do other than engineering. We had to build the initial product and come up with the product vision and try and win over the customers. And then now we're a much larger company, 10,000 person company. And so my job is to support, and manage large teams of engineers. So my day job today is that there's around a 500-ish person team that focuses on our AI and data science product areas. So that's my official job, and then is supporting that team. And then unofficially, as a founder, you kind of never lose the job of founder ever. So that is like a whole other job, and that involves company, product and culture directions and leadership hiring, and occasionally crisis management. It's just like an all-consuming job. It's kind of like being a parent. Like maybe your kids move out of the house, but you're still kind of their parent always, if that makes sense.
Yeah, and I think what's super impressive, like it's like being a parent, and it's your first kid, and like the kid is doing really, really well. So I guess congrats on that.
Thank you. Yeah.
And I'll be curious. You mentioned that you're working with the co-founder. So how do you split the area between the co-founders?
Yeah, I would say all of us have roles that are a little bit different. We certainly lean heavily on product and engineering. So that's really our background and our passion. And in my view, a company ultimately is the product that it sells. That's really what it is. Sometimes people get confused. They think, oh, the company is like the org charts and no, it's really about the identity, and the soul of the company is the product. So most of us stay involved in the product and engineering side. and as we scaled, we brought in really strong leaders to lead the different functions. So like, we have head of sales, head of marketing, head of product. I think you interviewed Adam Conway. I saw that interview. Um, so that was also part of the important for us in making the company successful, is that we realized we have to like bring in other great people and let them cook, so to speak, and let them be great and build out these functions. And we have to decide what we as the founding team want to focus on. Um, and we're always happy to jump in and help. Like I jump in and help sales whenever they ask, but there's people that's their full job and that's what they're doing. And within the founders, I would say we've each kind of found areas that we're particularly passionate about and competent in. As you've seen, like Reynold is very, very focused on our core data warehousing and SQL analytics kind of product portfolio. That was what his PhD was in. That he knows that space extremely well. And Matei and I focus more on the AI side of the house, day to day. But it's not static. We each are just jumping in where it's needed and where we can help. So I expect those things will change as they have changed over the years.
And so do you work on at the product level, helping deciding what to build and stuff like that, or is it more like management of teams and you rely on the PM to know what to build at the end of the day?
Yeah, I work heavily on the product definition as well and the product strategy. And I think the job of the leadership the job of the leadership and the founding vision, the founding team, is to create the vision and the framework of like, where roughly do we want to go? Like, what roughly do we want the product to look like? And what is the strategy? What are the advantages we're exploiting when we choose this direction? But that leaves a lot of room there's still many degrees of freedom within a particular strategy. And then we have to work closely with the teams of PMs, and it's not just PMs, it's tech leads also. At Databricks, the tech lead and PMs kind of work closely together on filling in all the details of what the thing actually looks like. So it's an important thing to also leave enough room that those people are empowered and they can really define exactly what things look like. But I would say that all the founders are pretty hands-on when it comes to product. As Yusuf, before we started recording, Yusuf was telling a story where I guess I reached out to you to ask about some customer use case, like late at night one day. And that's very common behavior by me and other founders.
Yeah, Patrick, you mentioned that with the co-founders, you're shaping the future of the product. So how do you decide how to staff the engineering team on which project? I know it is something super complex to do.
Yeah, great question. I wish it could be simplified to an algorithm, but it really can't. And it's one of the most difficult things, because when we look ahead, we see this universe of things we could build. And many of the things have amazing justification for them. Like, we could go in so many different directions, and there's customers that would love that. We ourselves think it's cool and innovative. But the universe of things we can build is so large, and it's infinite, and then the number of resources and people and teams we have is finite. It's definitely bigger than it was in the past, but it nonetheless is finite. So then it's this problem of like prioritization, and what do you do and what do you not do? And that is much more of an art than a science. I think some frameworks we use are trying to do the most good for the most number of customers. So if there's a feature or something that particular one customer wants, maybe it's really important to them, but it's not generally reusable. It's not generally something where we can get leverage out of it, where we can build it once and then it has benefit to many, many people. That we try not to do too much of that, because every feature you add, it adds also complexity to the product, and that complexity is itself a big cost and a drag on everyone. So we try to build things that have very broad utility. Another framework is that you want to balance continuing to improve your current product area and then entering new areas. And in fact, this is like some things that many companies, they build one great product, they bring it to market, maybe even they go IPO or they become, but they're not able to really do the next thing. They're not able to do the next act. And why is that? It's because you end up there's so many great ideas to do within your current thing you're doing. And that list becomes infinite, and your customers are loud and they want things, and you have to like do what's right for the customer. So I think the other framework we try to use is make sure we're retaining a certain investment portfolio for the future. And I think that's one thing I think Databricks has done relatively well compared to others in the market. Is that, like, for instance, we were really a great data engineering platform for data engineering and for some of the machine learning workloads occasionally, but then we wanted to get into the data warehousing space. This is the SQL analytics space. And I promise you, we had a full list of things on the data engineering side to keep doing. Like, we could have kept everyone busy doing those things. But we wanted to carve out space to enter a new market and to attack a new type of product. So I think it's this is another consideration is how do you balance what you know you're good at and what you hear from your customers as incremental improvements you can make, and then entering new markets and tackling new areas. And yeah, it's just very difficult and requires a lot of practice to get good at.
And how do you navigate like purely new market? Because you mentioned DB SQL and SQL. Like if you go and build a warehouse nowadays, I mean, it's technically it's not easy, but like it's not a new, like you kind of know what to build in a way. Like you know what the customer wants. But like if you take GenAI, it's so new. Like we don't even know what it's going to be in a few months. How do you, and it's so far away from, I guess, your initial PhD and what Databricks was when you started Databricks. So how do you navigate that? How do you know what to build and what to do? You know, where is the market going? Like, it seems really hard. Like, do you talk to, I don't know, leaders? Like, how do you manage that?
Yeah, so it's a good question. So first of all, I wouldn't even say it was trivial to enter the SQL market, to be honest. Although you're right that it's a more mature market, so it's maybe more known what customers want and how you succeed. That also means there's lots of entrenchment. There's incumbents in that market already. There's very mature existing solutions. And the bar for moving from what I have to some new solution for a customer is very high. You better give me something that's much, much better or much cheaper or something. So we needed to have a unique angle when we approached that market. And the unique angle we had was that we have this philosophy of like have a data lake type approach. So we can give you really fast SQL on your existing in-place storage where your data already is. You don't have to load it into a new system, and that significantly saves cost and stuff like that. So I would say that even that was non-trivial. Now in the AI space, it's a very different type of market because it's a nascent market. It's a very new market, and that has some benefits when it comes to our strategy, which is that there's not a lot of entrenchment because there is no. I mean, there's such a there is no GenAI vendor that's 15 years old. Like it's not defined. That's the null set. So that means that customers are much more willing to try things and to experiment with new vendors. The downside is that the terminal product shape is not defined. Like the terminal product shape of a data warehouse is defined. It's been pretty much the core interface people are using has pretty much not changed for 30 years. The interfaces in the GenAI space are just being built. So it's actually more like when we built Spark. When we built Spark, the big data interfaces were not mature. In fact, I would say one of the main things Spark did was that it defined a very standard interface for doing large-scale data processing. And at the time when we built Spark, there was like many different point solutions. There were point solutions that were very focused on like streaming workloads, and then there was point solutions that were very focused on, these kind of OLAP or analytical roll-up type computations. And there was point solutions that were very focused on sort of slow batch jobs. And what Spark did is we built a decent enough API that you could kind of standardize in this API, and almost like many of the different workloads would work with this API. That's exactly what SQL was like 20 years prior to Spark. But that doesn't really exist yet in the GenAI space. It's actually more in the point solution space. There's like vector embeddings for doing some type of semantic retrieval. There's like, how do you build evaluations and measure the quality of your app? There's like, how do you handle memory and conversation management? And there's this foundational token layer of like, I get my tokens from one of these different providers. and those providers have different trade-offs. So the way that people build these AI apps now, it's very much similar to how people built big data apps in like 2009. It's a lot of glue and stitching different stuff together, and the capabilities are very powerful. That's why people are bothering to do this. You wouldn't bother to like do all this work if you weren't getting something very valuable out of it. But the API layer for how you build these apps is like not defined, and that's certainly the crux of. By the way, it might take several years for that to happen. It's not going to happen like super quickly, but that is really driving our strategy here in this area. Is like, how do we start to define some of these higher level APIs, mirroring like the Spark API or SQL, where you can build some higher level APIs, and then a lot of the complexity that currently people are having to do is taken care of for you underneath those APIs. And exactly the shape and form of those APIs is going to take some experimentation. It's not going to be like a slam dunk the first time. In fact, Spark's current APIs are actually very different than the very initial ones that we built, and it took some iterations. So this is a nascent market, and the most important thing is to just listen to customers and try to think about where you design the right abstractions. That's kind of like what our central challenge is.
Yeah.
And there is like I've seen like a huge push on the GenAI part, but what about the classic ML? I mean, is it still something that industries are really using? Like nowadays, like everything is about GenAI, but I've seen few announcements or improvement in the classic ML. I'm talking on the general space.
Yeah, so I think we took a slightly different tack at Databricks than some other vendors in this space. We've actually accelerated and invested a lot in classic ML in the last few years. And by the way, certainly GenAI is a huge focus area, as I just talked about for a long time. But in my experience, classic ML isn't going anywhere. And in fact, there's just certain things. These generative models are really good at giving you what is really their core function. It's to kind of map a distribution of human language and give you human-like answers to questions and be like a human. And they're really good at like, so for applications that you'd otherwise have humans for, you can now plug in these generative models and they do a pretty good job. But there's lots of types of applications where humans were like never very good at them to begin with. Like a very, very smart single human wasn't actually that useful to you in this type of application. So there's tons of numeric stuff like fraud scoring, risk detection, recommendations, where it's actually not clear like the generative models are the right types of models. By the way, it might be that deep learning is relevant. So there may be neural networks in deep learning. So I don't know if you consider that classic or GenAI. It's kind of in the middle. I would call it like, just code-based deep learning. By the way, there's huge customers we have doing computer vision and this kind of stuff. So we've continued to invest heavily in like what you might call, let's call it code-based or model-based ML. And we actually see like significant growth in those as well. And what's kind of cool is in some ways the GenAI boom is giving all these AI teams out there more budget in some sense. So like they're able to better articulate to their leadership why it's important to invest in this automation. And that it's almost like a rising tide. All the boats are going up, and the GenAI stuff is growing, but also the classic ML is growing too. I do think there's another angle to this too, which is that in the same way that GenAI is pretty good at writing code, our findings are also that GenAI is like pretty good at building classic ML models for you as well. So we kind of touched on this with AutoML, our first AutoML efforts a few years ago. That was not using GenAI, it was just using some kind of parameter sweeps and stuff. But it turns out that if you're trying to do a quick regression or forecast or something like that, GenAI can go code up that forecast for you. And so that's another way in which these things like complement each other rather than one replaces the other, is that more and more we're working on this data science agent, and for tasks you're doing where you really a classical model is the right tool for the job. That doesn't mean there's no GenAI in the picture. Like the GenAI might be helping you select and even writing the code and running that classical model for you. So I don't think it's an either or. I think it's like They just have very different types of strengths. And I don't think people will be using GenAI for like forecasting anytime soon. They might be using some deep learning though, some deep learning models for forecasting. Does that make sense?
Yeah, I
Yeah,
think
yeah.
I was about to ask about AutoML and see, what was going on here. But I think you answered that question. I think it makes sense. Like the kind of old way to do AutoML, and seeing that as being just part of the AI Gen AI stack as some kind of agents system that's gonna build all the classic ML really makes sense. I think so. Like just doing the glue like that, I think clearly that's gonna be the future.
Definitely. I also think a major area of focus for us is, and this is across all of Databricks, is like many of the things. So the people that work with Databricks, they're data analysts or data scientists or data engineers, or more and more often, people that work with Databricks are just consumers in some sense. They're just someone else made a dashboard for them, and or a report, and that report might involve models or forecasting, and they're just a person that's consuming it, and they're using Databricks. All of those can be significantly enhanced with GenAI. So if you look, a lot of our product surfaces, what are those people doing? Well, data scientist is creating the model. I just gave you that example. So as I said, GenAI can help them build that model. A data engineer is building a data pipeline. We think GenAI can help them build the pipeline. We've even built some new interfaces for iterating on pipelines using generative and natural language interfaces. A consumer probably just wants to ask questions. They probably don't want to operate at this lower level. They just want to say, hey, maybe someone shared a graph with me. Hey, this graph only shows, the last 2 quarters. I actually want to know the last 6 quarters for this thing. And by the way, how does this change if I add new customer segments to, this report that I'm looking at? All of those can be significantly improved with GenAI. Initially, I use the self-driving analogy. Right now, it's kind of like the equivalent of like lane assist, like keeps me in the lane, and I can, adaptive cruise control, so I can stay the right distance behind. So it's assisting me, but it's not doing everything for me yet. But we're actually getting fairly close to, these higher levels of autonomy, where it's like, oh, I can actually just ask a question, and the AI is just going to figure it out on the data question for me. And so that's another area that I'm very focused on and I consider that across all of the Databricks product portfolio. I actually think the new interfaces and the new product surfaces are going to be very different, leveraging these Gen AI tools.
Yeah, and just for like you mentioned, talked about the DS agent. So this product just amazing. You can just ask to do data exploration, doing forecast, for example. Like it will build the data model for you. It will do data cleansing. You talked about like Lakeflow Designer, where like can help increase the productivity of a data engineer to clean the data, do the transformation just with prompt, with prompting. So we are like adding the GenAI to increase productivity everywhere across the platform. And that's what leads me to the question, like we launched many agents. So what's Databricks' strategy with the Agent Bricks?
Yeah, totally. So Agent Bricks is our product area for people that are themselves making Gen AI applications. So like, just how we are reinventing our products with Gen AI, our own customers are as well. So they all love that their products become much more intelligent, that they can interact with users and so forth. And I think I mentioned to you, the real challenge in this early type of market where everyone is building everything with their own glue and 30 different pieces and pulling some open source stuff and getting it working is that the higher level interfaces aren't there yet. So Agent Bricks is like our first basically set of higher level interfaces. And we focused on a few different use cases we see people doing with Databricks. So one of them is like, I would call it enterprise intelligence or corporate intelligence type of thing. So these are like internal apps that they're building, often to have some corpus of information and allow for high quality Q&A amongst their internal employees and sometimes external over this data set. So this is kind of, we call it a knowledge-based Q&A. So you have some some knowledge base that could be structured or unstructured data, and you're trying to build some like really high quality interface to that. And then we have a few other use cases where we've seen, but the principle in all of these is like what we think that our customers should be focused on is pointing us towards the data sets that are relevant to this AI they want to build, and maybe giving us some evaluations. So saying, hey, these are good answers, these are bad answers. All of the complexity of dealing with how you tune the search parameters, and how you deal with guardrails, and how you collect the feedback in a good way, like that is not a thing our customers should have to worry about. That should just be done for them automatically by the system. They should be worried about the things that are specific to their use case, which is things like evaluation and did this get the correct answer, and guardrails and all of this stuff. So I would say that from a product philosophy perspective, the idea of Agent Bricks is like, let our customers move way faster by letting them focus on the part of the problem that they know, that's their business. And all of this like work of tuning and experimenting with different models, and sometimes we even do model distillation or model fine tuning under the hood. That's like PhD rocket science stuff that the average enterprise should not have to deal with. They should just in the same way that in SQL, they just write some query that explains the gist of what they're trying to do, and things like how you optimize the joins and the network performance of moving all the data around to actually manifest that result. That is absolutely not something they have to worry about. So I would say Agent Bricks is like our first go at these higher level AI interfaces for common tasks we see in building GenAI apps, and we're going to be continuing to evolve it. Right now, there's 4 or 5 that we're working pretty closely on, but I expect there to be more over time.
And so I'm curious, what's your view on the way user will create product in the future? Like we see, like I tried Cursor, and I'm using Cursor and Cloud Code and these tools quite a lot. And this makes me think, do you think it's going to be at some points a world where, like, to some extent, Databricks does not even have a UI, and all we have is just some kind of tool we share, and then you just go and you use your AI tool to build everything, and you would say, hey, get me a pipeline to ingest the data, and then I want some knowledge, assistant, something to do something. And then at the end of the day, Databricks is just giving you all these kind of blocks and resources to do all the job. But like user would just be using super high level LLM, and they don't even go to any of these services. I mean, not even Databricks, like all of that. What do you think?
Yeah, so it's an excellent question. By the way, I don't have the answer for you with certainty. I have some ideas. If I knew exactly how all of AI software will evolve, I would be like placing lots of bets and knowing that they're going to be correct. But the industry is evolving in sort of 2 approaches. One approach is like completely text based. So this is like you're interacting with text. The interface between all these different software agents is text. By the way, it's almost captured in these 2 examples you gave, the two types of approaches. So Claude Code is like CLI based. It's like, this is your CLI. I speak text, and that's going to be my interface to you as the user. Cursor is like more of a fully integrated product UX that is like significantly augmented with AI. So we even inside of Databricks maybe have a few examples of both these. So for instance, Lakeflow Designer is really like a point and click. You're kind of iteratively building an artifact. You are at times entering text or doing generative AI type actions, but you're in the midst of like a very rich product UX. There's other parts of Databricks where we have GenAI features where you're just really like at a prompt. It's like kind of teletype back to the old days. And some folks think, oh, well, that's in the future, it's just going to be like one textual interface, and that's going to intermediate like all access I have to other products. I'm a little skeptical that that's going to happen because I think these UIs are very rich. By the way, it doesn't mean that they're not going to be like AI backed, but I still believe that like the reason why these models all use text at the beginning wasn't because everyone thought that was the best way to build products. It was just that that's the thing the models were really good at, is they were just like really good at doing text prediction. That's basically what these initial models were good at. So So I see it more as like an incidental starting point, but not where we're likely to end up. I think UIs are very powerful for conveying information and for capturing state as someone is building up, a pipeline or building up something that they, and I don't think it's going to be super possible to like intermediate all access to software through a text interface. I think that's going to be not the way things go in the long term. But I don't know it to be 100. I don't know 100% to be honest.
And to go back just to agent bricks for now, it's an easy way for a data engineer and data scientists to build agents. But what about maybe the long-term vision? Are we going towards maybe making them easy for business users or end users to build agents on Databricks, or it's still gonna be for, let's say, technical people?
I think there is a path for. I think the first thing we want to do for, let's say, non-technical users is really just question answering, and that's less the scope of the agent bricks and more things that we're focused on in other parts of the product. I think if you simply just get question. By the way, our results on question answering are getting pretty good. I would say right now, we have this Genie product. In Genie, there's a little bit of curation that happens, so it's not like it's analogous to like a self-driving car, but it's on a closed course. It's not out in the city yet. Someone designed the course, and it's safe because you're in this safe environment. So the analog of that is in Genie, someone curates a space. They say, here's the data sets that are relevant. Here's some example queries. But if you're in that closed course, you're getting pretty good answers right now. And some of the stuff we have internally is much better than what's in the product today. So you have to a little bit take my word for it, but just wait a month or so. But it's not an open course. An open course is like, I didn't curate any data sets. I just show up and say, no one gave you example queries or verified queries. And I just say, hey, give me this answer. And the AI is good enough to give you the answer. And more importantly, it's good enough to know if it can give you the answer. And it doesn't just make stuff up if it's wrong. We're not there yet, but I actually think getting there is a huge. By the way, we're not super far at Databricks. Some of our internal research stuff is getting very close to this. So I think that getting to for the less technical user, the first big win is just, can we answer data questions for them, and that might take some time, but I think that's like a huge unlock if we can do it with just like really high fidelity, because then. In your company, you could give Databricks at least this question answering part to every single employee. Why not? It's just, you just ask questions. I think the idea of a lay person building a model or building a data pipeline or building some of these more complex assets is further out. And that's not our immediate focus right now, just because there's so much of a win in front of us with question answering. I would say the way we approach these more advanced things is more augmenting already somewhat technical users. So if you look at Lakeflow Designer, the assumption is the person in there is kind of technical enough to really know what this DAG that they're building is really doing. And, they can even eyeball a SQL expression and be like, yeah, does this seem like it's doing the right thing? So I would say that we're more in sort of augmenting mode for those users right now, rather than fully automating.
Yeah, and I think it makes sense because it's going to take some years before we can remove all the data engineering jobs and all these, requirements. So I think it makes
it's
sense.
just much more difficult problem than answering an analytical question.
But I still think we're simplifying the journey. If we take the example of someone using Lakeflow Connect to ingest data from Salesforce, once the data is in the data lake, then you can use Designer to quickly transform the data, and then go to Genie and use this data to ask questions and give them to the business user so they can ask questions immediately, or dashboards. And this could take maybe a few years ago, I don't know, 3 months, 4 months. Now you can do it really quickly with some basic knowledge.
Exactly. Yeah. And so I think, in that story you told, there's still a semi-technical person that's setting up the core pipelines. They're hopefully doing it much faster and much easier than they could do before. And that's a big one. For instance, the Claude Codes and Curses of the world, they're still targeting a technical. They're ultimately helping you write code, and the assumption is that you kind of know what that code is doing as the person who's I still think it's not the point where if you just were completely non-technical, you could just click, click, click and expect these things to work. But they're a huge improvement in productivity for those people. So like that's still a very, very significant event that those things exist.
All right, I wanted to switch gear and talk a little bit about the Tecton acquisition that I saw in the news. Well, maybe let's start to explain what's a feature store, because I think Tecton is kind of they created even the naming of feature store. Yeah, what is that?
Yeah, so this was the name. That team did create the category basically of feature stores. And it's helpful to maybe define what feature means. And I think it can be understood in other terms too if people don't like the word feature, because it's a fairly simple concept. It all started when there were certain types of applications that really needed a lot of pre-computed information about their users in order to make a decision. So an example is I do fraud detection. I have a very short amount of time to decide if a particular transaction is fraud. And there's a lot of inputs I would love to have available to me when I'm doing that check, the fraud check. I would like to know, how many transactions this particular, let's say it's a credit card swipe, how many transactions has this particular person done in the last week? And how does that compare to their average number of transactions every week? What is the location? What are the top 5 locations this person typically does transactions from? And how does that compare to the location that they're in right now? If someone 90% of their transactions are in San Francisco, but suddenly they're in Botswana, like it's a reason to believe there might be something a little atypical about this particular transaction. What is their current account balance? Are they above or approaching their credit limit? How many other transactions have they done in the last 30 seconds, or last 30 minutes, or last 24 hours? So it's very expensive when you have something that's on a tight budget, time budget like that. You can't go and run a million queries to compute all those things. Like you don't have enough time. So you have to pre-compute them. So these inputs, by the way, these inputs are often fed into a machine learning model that then computes the probability of fraud. So we'll have all these things that you've pre-computed. Those are called features. So it's a fancy name for like a pre-computed statistic, basically. And it's funny because this team started at Uber. And at Uber, the big problem that they have was ride time prediction. So like that was just like one of the major use cases they were focused on. So this is a while back, but like when you get an Uber, they want to predict how long, I think it's both the wait time, like how long till I get this person comes to me, and then also the time it's going to take me to do the whole trip. It actually gives you both. So it turns out that also the thing where you can't afford to like do a bunch of computation as the instant someone, you have millions of people requesting rides all the time, and you need to get very fast those. So all the inputs to those algorithms need to be like pre-computed and then refreshed constantly. They need to be kept up to date in basically a cache. So that cache is called a feature store, and those metrics are called features. That's basically what that means. And it turns out that in classic ML, especially for these like fraud detection and personalization type use cases, this pattern is like very, very common. And it's actually really hard to do it yourself. You have to somewhere you need to define these features. You need to completely keep them refreshed all the time. You need to also make sure that they're defined in the same way for your like online application that they are for your analytics. So offline you might go run a bunch of analysis of maybe you want to improve your fraud detection models. So you want to go run a historical analysis for the last year and simulate how you would have predicted the fraud, and then compare that to whether some later ground truth you found out that there actually was fraud or there wasn't fraud. You need to go like recompute back in time all these features to do your sort of like simulated analysis in order to improve your model. So that whole domain of computing these metrics real time, defining them, making sure they're consistent between offline and online, that is what feature stores do. And they're sort of layered on top of the lower level compute and data infrastructure. So it's funny because Tecton was actually a company that was largely built on top of Databricks. They built these higher level APIs that then underneath, and they did target other platforms, but their most popular underlying platform was Databricks. So why is any of this interesting? Well, it turns out in the AI GenAI space, more and more applications are becoming personalized and contextualized. So Gen AI applications are able to be much more rich and individual, and they almost need to be. So for instance, in our own data science agent, the one I just mentioned to you, that's like helping improve data science workflows. Well, it turns out that like knowing the actions you've just done, the last 20 commands you've entered, is like extremely helpful in informing the decision of what the next generated output should be. And knowing the data sets that you personally frequently access, or the last 20 data sets that you've accessed. Because these AIs are able to, in a similar way to those fraud detection models, they're able to take like very recent information that's just happened and then use it to help inform like the decision that they're going to make in terms of giving you a useful future output. So this problem of like having very fast and online access to computed features, which is really just like some user related metrics, is actually becoming like really important now in a new way for sort of different reasons because of this Gen AI based applications. So Tecton was like a really strong team. We knew the team well. The product was already running on top of Databricks, and the type of problem that they know how to solve, which is this kind of online serving of these very, very difficult to compute user metrics, is like becoming very, very relevant now in the Gen AI world. And for all those reasons, and we also just knew the team for a long time and thought highly of them. So that was one of the main reasons why we did the acquisition. And yeah, so that maybe gives you some sense of why this is useful to us. Does that make sense?
Yeah, and you mentioned that feature store, like I'm talking about Tecton, and how it is related to the agentic workloads. And during the acquisition of Neon, we also mentioned that they were like, I think 80% of the Postgres tables was created by agents. So I believe we're stitching Tecton with Neon and also with the recent acquisition of Mooncake. So how would be the interaction between those?
Yeah, makes sense. So these are all complementary to each other. And as I said, Tecton is focused on the higher level interfaces and then the logic to be computing these features, but they don't actually provide storage themselves. So they would always run on top of other types of storage. And remember, there's like the online and the offline. So there's the offline storage, which is like your core data lake. Then there's online, and that needs to be a very, very fast. Like, this example I gave with predicting the ride time for Uber, or for fraud scoring, or for like pulling the last 10 commands I ran to make sure that I'm giving the right next result for the agent. Those cannot be slow. Those need to be very, very fast. And so the backing storage needs to be storage that can do like relatively fast key value lookup type things. Until fairly recently, like Databricks actually didn't have such a storage solution. So even our own feature store that we had, because we also had a feature store, it was not as good as the Tecton one. Even our own feature store, we would like tell you, oh, you have to like maintain your own online thing, like use Dynamo or use like Redis or something. We'll help copy the data over, and our own customers were like, hey, why don't you just do this inside of Databricks? Like, why can I just not do my online serving in Databricks? So part of the Neon acquisition was about basically. By the way, it was kind of interesting. We were already working with similar technology on a similar technology stack, but it was kind of similar where the team was really good. They had developed a lot of expertise in this kind of Postgres-based online database management, and it just fits in super nicely with the other things we're doing, which are also trending in this kind of online direction. That we thought that was a really good opportunity. So I know it can seem like this jumble of like different technologies and different companies, and what the heck, is there any coherence to this? But hopefully, actually, my hope is that the average customer is interacting with very high level interfaces, and how exactly the feature computation and the online storage and the offline storage are synchronized their data, like that should not be something our customers need to worry about. They should focus on defining at a high level their applications, and we should be dealing with all of that complexity. So hopefully, like, people see that as a positive, that we're in a prior world where you might have had to work with 4 different vendors and glue stuff together. Like, this is all going to become part of one pretty coherent application platform, basically, for these AI apps.
Well, I think it's a perfect way to close it.
Yeah, well, thank you guys for having me, and I've enjoyed as practice. I looked at, so I watched several of the other podcast episodes, and I learned a lot. Even though it's people I work with every day, just hearing them in this context was very, very interesting. So thanks for the work you guys are doing.
Well, thank you so much for your time.